So we were discussing the optical activity, and as a part of that, I was telling you what is an ordinary light. You have ordinary light, which is having all wavelength, all possible wavelength of the visible light. The wavelength is ranging from 300 nanometers to 700 nanometers. The 700 nanometers is red. Remember that higher wavelength is red, violet is having lower wavelength. Okay, so it is increasing order down. Wavelength is increasing down along the from here to here, and energy is decreasing. Remember that energy is decreasing, and frequency is also decreasing, because you know it is inversely proportional to this, inversely proportional. Okay, now, so that is our ordinary light converted into monochromatic light. How do you convert this into monochromatic light? You pass it through a prism, you'll get the 300 to 700 being separated as with your, see, this will be V, and this will be R, and then you have a slit in between, a small hole. You rotate this prism, you can choose the right one, the right wavelength you want. That is one method. Second method is use a separate source of light like sodium vapor lamp, which will be having 589 nanometers. 589 nanometers. Both the methods you can use. Normally we use a single source of light. That is a better method. Unless and until you want to make a study of the optical activity, a variation of optical activity with wavelength. Suppose you want to make a study. How will the optical activity of a compound change when you change the wavelength of light? If you make that type of a study, you will use a prism or nickel prism, whatever is that. Okay, so this is what how you get a monochromatic light. Now we have to convert this monochromatic light into a plain polarized light. Plain polarized light. Plain polarized light. Now, what is a plain polarized light? Monochromatic light means single wavelength. Monochromatic light. One wavelength, single wavelength. So for example, yellow is having 589 nanometers. But this is moving in all possible direction. In all direction, all plane. What do you understand by the word plane of wave? See here, look at one wave. Here is a wave which is passing in a plane on the plane of the board. Okay, this is passing on the plane of the board. Suppose you have a plane, another wave which is passing in a perpendicular plane. See here, let me draw it. Let me see whether I can draw it properly. See this. Can you imagine it? See, this is in this plane. Now this is moving in this plane. Okay, in a XZ plane. This is your x-axis. This is your z-axis, and this is your y-axis. Okay. Now this is the first one. This is moving in the YZ plane. YZ plane. That means it is touching. See, this is the y coordinate of this wave, and this is the x coordinate of the wave. z coordinate of the wave. Okay, and this second wave, it is moving in the xz plane. XZ plane. Okay, I hope you can understand this concept. So I can have another plane, another wave which is moving in this direction. See here. See this? This wave is moving along XY plane. This is X and this is Y. XY plane. So you have mutually perpendicular planes. Now this is the only three which we described, but you can have any other. See here. Look here. Still bent. Slightly bent. So this is a monochromatic light. All possible direction in all possible plane. In all possible direction, in all possible plane, but only one wavelength. That is monochromatic light. So just think of waves which is moving along this direction. You have 1, 2, 3 waves here. Now what you have to do? You have to convert this into a monochromatic light. That means you block all the waves except one which is going in a particular plane. Right? Again, see, when I draw this in a very big picture, things will be too simple to visualize. Now again, you keep a slit here, a small slit. Now the width of the slit, remember the width of the slit is so small that the width of the slit is so small that the wave which is passing in this direction, in this plane only comes out. The waves which is passing in the opposite direction, like this, it is not coming out. Because it is something like, here is a slit, and here is a wave. There is a plane of the wave. Think, this stick is a plane, cannot pass in this direction through this slit. If you want to pass this stick through this hole, you have to hold it this way. Here is a stick. You can pass through this stick through this hole only if you are bringing in this plane. Okay. So if you are holding this stick in a perpendicular plane like this, it will not come out. So that is what you are doing here. You are allowing only one wave to pass through the slit, preventing all other waves from entering it. So now you have one wavelength, one plane. Now what is this type of slit? This is called a Nicol prism. Nicol prism is used for this. Nicol prism, sorry. Even now the internet is very slow. Nicol prism. Or you can use what you call as diffraction grating. Diffraction grating. You must be knowing what is a diffraction grating. It is some sort of, I am not very familiar with your the whole stuff physics, but what I remember in my older days is that it's a set of parallel lines which are very close to each other. That is, 1 lakh lines. 1 lakh lines per millimeter width. Think about that. Okay, if you draw 1 lakh lines per millimeter, that is a type of substance which you call as a diffraction grating. So the wave, the wavelength is of the order of nanometers. 700 nanometers, 300 nanometers to 700 nanometers. So the space between the lines, the gap between the lines should be, should be smaller than this. The gap between the lines should be smaller than the amplitude of this wave. Okay. So the distance between the lines, the distance between the lines, the difference, this distance, see here, this distance should be less than this value. One second. Yes. So this distance is so that any wave coming in a perpendicular plane will not pass through it. Only wave which is coming in a vertical plane, in the plane of this, along this plane, only will be entering through and going out. Okay, so this is what is meant by a plane polarized light. Now the question, what do this plane polarized light do? When you pass this light through an optically active solution, through the solution of an optically active compound, what happens to this plane polarized light? To the plane of the polarized light. Now let me give a typical thing, like the light is passing through this. This is the situation when you have a long tube in which you have placed pure water and you allow the light wave to enter through this. And now you keep a small slit here, which is aligned parallel to the slit on this side, through which your wave is coming. If you keep this slit here, and if you have only water, then when these two slits are parallel, arranged parallel way, you will be able to see the light which is coming out from here. This is your eye. You are observing from here. You will be able to observe the light. It will fall on your eye. It will fall on your eye. That means the one which is entering here is not getting disturbed by the slit. Suppose you rotate the slit. Suppose you rotate this slit. What happens is you will get blackness. That means the light is not reaching your eye. That means only if you have two slits parallel, it will come to you. Now, so you arrange these two slits such a way that you can see the light which is coming from here through the second slit when you put water. Is that clear? This is the first part of the experiment. You allow the light to pass through a tube containing water. Okay. Now this is what is this called? This is called the optical activity cell. Optical cell. Just a tube with a small hole here, with a cap. It is closed on both the sides, with closed on both sides with which allows the light to pass. Okay, are you able to hear what I'm talking? I hope you are able to hear. Okay, now, so you have arranged the two slits in the instrument. This instrument is called, I think the board has disappeared, right? The board has disappeared. Internet connection. Even now, it is the problem. Let me see whether I can get the connection again.